Hey robot makers, hope you're having a good day so far. So do you want to know how to build your own RGB LED coat for your dog or Cyberdog that's controllable over Wi-Fi using a Raspberry Pi Pico W and MicroPython? And do you want to know how to completely over-engineer a project? Then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. And today has been particularly fun. So let's get over to it and we can talk more about this. So yes, this is all about Cyberdog, or RGB LED dog coat, which I have on the desk behind me. We'll have a look at that in a moment or two. So yes, this is all about how we build the Cyberdog coat, and I'm going to show you a little video clip of testing it around Blackpool illuminations last night. It was absolutely loads of fun to do. There's loads of people turning and looking at it and so on. So we're going to have a look at the build process. We're going to have a look at the features. We're going to have a look at how to wire this up, general LED strips and addressing them when they're in an arrangement that's not just a single line, algorithms on how to figure out which pixel to light up if you're doing like an X and Y in a grid. Some of the issues I came up with and had to deal with when building this, and if you're watching live, we'll have a bit of a live Q&A after the main show as well, so stay tuned for that. Okay. So the aims of this project. So I wanted to build an RGB LED dog coat for Archie. I actually want to make two of them. I've got a blue one and a pink one for Archie and one for Minnie. I want to make this controllable from my phone. So I want to be able to walk my dog and have my phone in the other hand and sort of, type a message in, have that scroll across the sort of grid on the back, change the color patterns, all that kind of stuff from my phone. So that's kind of what I'm aiming for. And if you think about the last couple of weeks, the videos that we've been doing, they've kind of been building up to this. So we did one about how to communicate between two Raspberry Pi Picos, a Pico W and a Pico W, for example, but not over Wi-Fi, just using UART. And we've used that technique to connect the Plasma 2040, which is also a Raspberry Pi RP2040 chip on board, and the standard Raspberry Pi Pico W. We've got those talking to each other using this UART. And we did a show about how to create an access point, the Wi-Fi in the Woods episode, and that was how you can make your Pico W into an access point you can connect to from your phone, so you don't need to be on your local area network, so you can be out there on the promenade with your wireless access point from your dog that you can connect to and then control things. So yeah, this is kind of where we've been going over the past couple of weeks leading up to this. Okay, so the build process. So I started out with all the components I needed to build this project. So I knew I would need a Plasma 2040, which I've not got the design for, so I had to leave that off my 3D model there, but I knew what the whole arrangement was. And I can show you that on my overhead. I've got the Minis version here. So we have a gallium battery. So these are little batteries. Have I got another one to show you? That's what it looks like. These are 400 milliamp hour 3.7 volt LiPo batteries. That's having a real hard time focusing there, isn't it? And they're in this lovely hard case as well. So they're really nice and easy to sort of swap in and out. I then knew that what I wanted to do was connect that to this LiPo Amigo Pro, because we can connect the battery up and we can also connect a device to this, and we can turn this on and off just by pressing this button here. I've actually got this powered currently through the Plasma 2040, so that's actually back powering all the boards as well. On the other version, which I've got over here, you can just see it at the bottom of the screen. That one is currently powered and is running the dog coat there as well. So on this one, I've not actually got the Pico powered up, but basically we just take some power from these wires and then we connect them up to there, and then we power also the Plasma using the same technique. So just very simple to do that. Currently I've got just like a regular JST connector on there, but you simply just snip that off and it'll plug into the 5 volts and to the ground there. And then I would just connect the Pico to the Plasma 2040 just using some wires. It's basically just pin 0, pin 1, and then the SDA and clock pins on the Plasma 2040. And then the Plasma 2040 has got these great connectors on the end, these screw terminals, which we can then connect up to an RGB LED strip. So let me just go back to our keynote. There we go. So they're the components I needed to add to some kind of structure, and I was thinking about how was the best way to do this, and I thought maybe some kind of like saddle that would go across the back of Archie, across the dog. So I got a piece of paper and a pen, and I basically just drew out the arch of his back and figured out what that is, and it's about 5 centimeters by 130, I think it is, with basically a 3mm thick arch. And because it's an arch on Archie, it's quite strong shape. And then I basically just built some surfaces at different angles, and I think it's about 30 degrees or something like that, and the top ones are just completely flat. And then I just sort of put into there the holes, the mounting holes for each of these. And then one of my favorite things to do right now is using, let me just grab this, I'm not going to drop it, not going to drop it. I've got a box of screws. So these are all M2 screws on the top. I think there's M3s and some M4s as well on the bottom, but the M2 ones are absolutely my favourite. If I go to the overhead, I can show you what these look like. They've got a nice head to them. I'll just get that open, and I shall show you what these look like. So I'll just grab a few of them and show you. So these are M2, and they've got these nice sort of hexagonal shaped connectors on there. Just about see that there. So absolutely love these. They're really, really strong, really, really easy to connect up, and it's very easy to 3D print a hole for them. Basically, it's just a 2mm hole that they go through, and they're an M2 screw, and there seems to be just about enough plastic sort of overrun tolerance on the 3D print that it grabs hold of that, and you get a really nice connection there. So what else have we got? So the Plasma 2040, that's the amazing board from Pimroni, which is designed perfectly for RGB LED lights. They've got some really smart things in there, like voltage protection, voltage monitoring, so you can limit how much current goes through there and basically just cut the power if there's too much drawn. So you need to make sure you've got a power budget for all the LED strips. You can't have like a mile-long LED strip. You need to sort of figure out how many you need and how bright do they need to be, and you could potentially have more and just have them at half the brightness, or flash the pattern so that it's not as drawing of the battery. We've got the Pico W, so I've built loads of projects with the Pico and the Pico W in, so the whole spacing for that I know well on that one. 51 by 20, 21 I think it is, or 11.4 from hole to hole, 51 down. And then we have the Leica Amigo Pro, like I said, for the power and the charging. It manages all the charge. So basically got those things with a gallium battery on a design, and then I also needed to include something so that I could attach this securely to Archie comfortably. So I've created some holes on the very end to run through some elastic, and the elastic kind of goes underneath his stomach and also over his basically his arms are in the middle, so there's two pieces of a elastic strip. And we were thinking about what do we need to do with that? Do we need to sort of fold it over and then stitch it? But we've actually just got some Velcro, and the Velcro is adhesive on the back, and that seems to stick fine, and it was good enough for the event. So that's kind of what we've gone with for this. So the coat itself, here's a picture of the coat, and I've got it on the desk behind me. So in this case, I use some WS2812 RGB LED strips. There's one with 3 wires. There's also those with 4 wires. I've got some of those on my desk next to me here. And the 4-wire ones are the AP 102s, which are just slightly different. They have 4 wires instead of 3. This is the 3-wire variety. And where's the 4-wire variety? I think in fact, the one that's on the desk that's flashing away is the 4-wire variety. So if I go back to that overhead, this one has got the 4 wires there. So as well as having a data, it has a clock line as well. Works pretty much the same way. Not much difference apart from that. So they're the ones I've gone for on the dog coat you can see there. I printed out some 3D spacers. So these 3D printed spacers, the idea is we get our RGB LED strips, and we can glue these at specific intervals to keep them apart, so that across the entire length of the coat, the spacing and the sort of height and the pixels all line up in a nice grid. And that'll be really important when we want to scroll some text across it, because if we want to scroll text and they're not aligned, it'll look wonky and funny. Now the other thing is, these also help give some extra surface area. So when I was putting this together, I was thinking, do I want to get the RGB LED strips on top of the coat, or do I want them underneath the coat? I'd not really figured this one out until I committed to one particular one, which was I put them on the top of the coat in this example. So when I was printing these out, I made these so that they're actually flush with the height of the LED, so I could put some glue on there and it's a larger surface area without actually gluing the LED to it. So these would actually space it and also give a larger surface area. And then the one that I went with, I actually glued the back instead, and again more surface area. Now the LED strips I've got on the dog coat do actually have an adhesive strip all along the back, but I found that sometimes works well and sometimes doesn't, and I'm aware that I was basically going to flex this coat and I needed them to stay put. So I went with on the outside of the coat with a bit of over engineering. But these RGB LED spacers really worked well. They're really quick to print. I think it takes about half an hour to print just one of these, and you can print like about 12 of them in an hour or two. It's pretty quick to do. There's not much height to them, but they really give a good platform of which to stick everything to. So what else do I need to say about them? Yeah, so I glued these to the coat using Gorilla Clear glue, and that didn't work fantastic. It has glued them on. It takes a very long time. It's about 2 hours to stick there. I was wondering whether I should just use like regular super glue. I use this regular kind of super glue. This is a Loctite. I actually use that to stick the LED strips to the plastic spacer. So a mixture of different types of glue. So I probably used the wrong type of glue. I remember watching an Adam Savage video, and he said for every type of material that you want to connect to another type of material, there's a specific type of glue for that. So I've clearly not used the right one, even though I thought I'd researched this. It didn't quite work the way I wanted it to. You can also see there on the bottom of that picture there, and I can probably grab hold of it in a second to show you, the saddle has got a little piece of sponge on it as well, and that's just to give it like a nice soft pillow between Archie's back and any of the little screws that have got nuts holding everything together, just to make sure it didn't hurt him in any way. This is all about his comfort. And you can also see there that the LED strips have some wire. They've got 3 wires in this case soldered to each of the ends. Now this was another thing I was really nervous about. If I just grab one of these. When you cut these, if they're these really, really dense ones, there's actually not much space to cut, and you basically get half of the solder pad to be able to solder a new wire to. So, you know, you're really not talking very much area there. You're not going to get a lot of grip on that, and that's one of the reasons I also went with the sort of spacer, because that could, as well as holding everything the right distance, it could mean that these don't move around and they're not taking any of the load if anything bends or anything, because I didn't want them pulling and then snapping off, you know, when we're in the middle of nowhere and he's walking about flashing away. I don't have my soldering iron to hand to fix that, so it would be a bit of a pain to sort of try and unglue everything, solder it, and then put it all back together. So they were the things I was most worried about with this build, that they would flex and bend and break off and snap because of them connectors being so small. I think I'll probably go for the larger spaced LED strips in the future, a bit like I have around the room behind me. You can see these are actually quite, you can see they're quite far spaced apart. I think they're about 1 inch apart, something like that. Whereas these other ones are 144 pixels per meter or something like that. So that's the coat. And yes, this is some of the features of Cyberdog. So it's very powerful from a computing point of view. It has 2 RP2040 processors, so that's quad cores. We've got 2 cores in the array of computers there. It's got the Plasma 2040 as well as the Pico W. So the Plasma 2040 brings with it all those power monitoring and voltage limiting protection. The LiPo Pro actually has some limiting on it as well, so it can actually prevent the, you know, if the thing shorts out, if the wire's disconnected and shorted out, it wouldn't set fire or anything like that or go super hot. It'll basically just kill the power. So really, really useful, particularly if it's on an animal and we want to make sure that the animal's health and safety is our sort of #1 priority there. So of course it's remotely controllable, so we can connect to our Cyberdog saddle using Wi-Fi, because the Pico W is in access point mode using View, which we looked at over the past 2 weeks. And the idea there is you can go onto the View's web page that it's presenting via the access point, via the capture portal, the captive portal. You can type in some text and then that will scroll across the dog coat. That's a feature that's coming soon. I've not got that yet. Is he snoring? Archie's snoring in the studio. And I also want to have some buttons on there so you can change the different patterns. So currently on the version I've got now, it's kind of standalone. You can press a button on the saddle and it will change the different cycles of patterns. We'll have a look at that in a moment or two. Some of the safety features, so like I said, quick removable battery. We can really whip these batteries out. They've just got a JST PH connector on, very easy to disconnect that. You've got that voltage limiting protection, so it's not going to sort of take too much power and heat up. That was one of the concerns somebody raised on Reddit, was that, will this not cook your dog with the LEDs getting too hot? They don't even get warm with the patterns that I'm doing, and we tend to use it outside. Plus there's a bit of insulation, because the coat will insulate it too, because it's on the outside. And we've got that short circuit protection as well as part of the LiPo Pro. So LiPo Amigo Pro, so definitely recommend that. And then for his comfort, we have the foam pillow underneath. That's that piece of foam. We literally bought about 5 meters of this just for a tiny strip, because you couldn't buy it in anything less from Dunelm, I think we bought it from. And it has this nice soft elastic for the harness, and there's 2 pieces, and they just attach via that loop and some Velcro to just keep everything together. And because it's under a little bit of tension, the Velcro is sort of pulling in that kind of motion, so it actually keeps it stuck to the elastic, which is fine. After he's actually worn it, we can see there's quite a lot of dog hair trapped in the Velcro and the adhesive on the edges of the Velcro, so it might need replacing over time, but we could easily just stitch that. That'd be quite simple to do. And overall, it's a very lightweight harness. This thing doesn't weigh a lot at all, and that was one of the important things. We don't, these are small dogs. They haven't got a lot of, they're not a donkey or horse, so we need to make sure that the weight budget is very, very light. Now it's very, very bright. It's surprisingly bright, and I have these RGB LEDs at half power. I'm only putting out about 50% power, I think. So it's certainly not 100% power of these LEDs, and they are seriously bright. Now we're powering that off that 400 milliamp hour battery, so I was finding we would get about 15 minutes, 20 minutes, pushing half an hour, depending on what the light pattern was. So that was more than enough for what I need, and it's very easy to take up. I've got 5 of these batteries, just take a pocket full and then go out there and just change them in the field as and when we need to. It has 288 RGB LED pixels. I've counted every single one. Ask me how I know. The individual addressable LEDs means that we can actually sort of go on an XY coordinate on the grid, and we can light up a specific RGB LED pixel, and we will do that on the demo in a moment. And we can change the hue, the color of them. We can change the saturation of that color, so from really strong color to just white. And we can also change the brightness as well. So HSV, we can change all aspects of that, or use RGB if we want those values as well. And yes, it's a smart saddle, so we have lots of fun lighting patterns, very easy to change the patterns. There's onboard buttons. There's an A and B button on the Plasma 2040, and I make full use of that. One button will just stop the lights completely. The next button, the A button, will change the current pattern. So I've got a number of different patterns, and you can cycle through those, and we'll have a look at that in the demo shortly. And of course, there's an off button on the LiPo Amigo Pro, so we can simply just press that and it'll just kill the power to all of the boards. Nice and simple. So how do we wire this thing up? It's surprisingly simple to do this. A bit over-engineered. Some people on Reddit were saying, why don't you just use a single ESP32 to do all of these things? And I've used discrete boards because they are specialist in what they do, and they also have some extra features that make them really safe to do that as well. So on one of the projects I have, which one is it? There we go. How many minutes? How many minutes through was that? That 23. Was 23. Awesome. That was cool. Let me just move that back. So what I'm trying to get down is my little box of bits here. I have all kinds of goodies in here. And one of the things that I have in here, I think, I'm hoping it's in here after that. There we go. This is it. Put that back. So this is a thing I made for the 9,000 subscriber thing. It's a HAL 9000 board, and you can see there's a bit of blue tack, and there is also an RGB LED NeoPixel just in there, which makes that glow at the front. So if I added some power to this, which I don't think I've got to hand, oh actually I can do. If I go to the overhead, I can plug this in and show you this. So if I just plug in this and go to some power, there we go. So there's an RGB LED pixel in there, and that's just going to cycle through all its different colours. So you can drive an RGB LED pixel straight from a Pico or a Pico W. So I've just got the data signal to it, and I've also got a ground, like a 5 volts and a ground on there as well. So very, very easy to actually wire those things up. Okay. So the reason I chose these discrete boards is because of their extra features. So the Plasma 2040, like I said, it's got those screw terminals, so it's very easy to actually screw in and remove the sort of chunkier wires for the LED strips and the different types of LED strips. They also have that voltage protection and current monitoring as well, so we can make sure the LEDs don't pull too much power and basically just burn out the Pico. And we've also got the LiPo Amigo Pro, which has got this really good voltage protection and charging circuitry as well, so we can have the board either charging or providing power, and it seamlessly does that, and you just get the 5 volts out going to your Pico or to the Plasma 2040. So that's what I've chosen to do. The 4 things: we have the gallium battery, we have the LiPo Amigo Pro, and we have the Plasma 2040, which piggybacks its power from the Pico, and then we have the Pico, which connects to the RP 2040 on the Plasma 2040 via the SDA and what's the other one, SCL. And basically it's just a UART, it's just a serial connection with a receive and transmit, and they just crossed over as usual. If you want to know about how to do that, there is a full video on how to communicate between 2 Picos. So if you watch that one, that was what I was learning to do for this particular use case. And you can see there, so the GPIO 0 on the Plasma 2040, the Pico's GPIO 0 goes to the Plasma 2040's SCL, its clock. The GPIO pin 1 on the Pico goes to the Plasma SDA, which is the data, or again it's things like pin 20 and 21 at the top of my head. We've then got the Amigo Pro putting 5 volts out to the Pico W's V-bus, its voltage in, which is 5 volts. It then goes the ground to the ground on the Pico. And then we've got the V-bus from the Pico going to the Plasma 2040's Plasma 2040's 5 volts, and the ground on the Pico going to the Plasma 2040's ground. And then finally we have just the Plasma 2040's DA, which is the data, going to the APA 102 if you're using the 3-wire variety, or if you're using the 4-wire, which one is that? That is the 4-wire variety, I think. And the WS2818 is the 3-wire variety, I think, off the top of my head. But yeah, one basically just has an extra clock line, which is the WS2818. So if you want to have a look at them, we did do a video on Plasma 2040s way back, so seek that one out. And if not, there's a nice introduction video on the Pimoroni website as well, because I did that. Cool. Right, so one of the challenges when you start putting these LED strips together in this kind of formation is the numbering isn't what you expect, because essentially they're going to snake round. Now if we go to our camera, you can probably see there the connectors are snaking round. So they come in from the left hand side on that bottom row there, and then at the very end of the bottom row on the right hand side it then curls to the next row, and then snakes back, and it does this all the way to the very top of the coat. So that means if we want to address that as like an X and Y coordinate, we have to do some fancy maths. It's not that fancy, but it does require some maths. You can see there we have 288. If we start counting at 0, 0 is a number as well, that's where we get the 288 from, because it ends in 287. 0 is a number 2. So we have 8 rows of RGB LED strips, and each of them has 36 RGB pixels on it, so we can address each one of those. So you can address just using the standard library from Pimoroni on the Plasma 2040, you can individually address them. You basically just say which number starting at 0 pixel do you want to address. But if I'm doing this in rows and columns, I need to then apply some additional math on top of that. And what I looked at when I was looking at this, because I was trying to find what is the pattern. I don't want to just store every single number in a table and have it look that up. That'd be very quick, but it would also be quite wasteful of memory. We can just do an algorithm, a bit of math to figure this out. So if we look there, the very first pixel that we have is pixel 0 on the RGB addressing, and that's also just happens to be 0 on our grid as well. So that's nice and simple. But the next row is it goes from 71, and then the next on row column 2 on this one, 72 is the next one after that. So how do we change our algorithm depending on which row it's looking at? Because we can pretty much figure out what on the very first column, what the X and Y coordinates are, but the second column, everything messes up. So we need to figure out which is the odd or even column, and then just multiply by the number of pixels times by the number of the columns, and we can figure out on the odd or even ones which one we're actually after. So let me explain that a bit better just after this short message. So if you like this video, give me a like. Really appreciate that on the videos. Drop me a comment as well. Is this some fun project that you're looking at doing? Have you used any RGB LED strips yourself? If so, which type you use, the 3-wire or the 4-wire variety? And if you've not subscribed to the channel already, which most people haven't done, which always surprises me, so far we've had way over 500,000 people view the content on the channel, and we don't have anywhere near 500,000 subscribers yet. So let's get the numbers up there. We're heading towards 10,000, I think, by it's going to be this time next week, maybe a little bit later. We should be hitting that number. So really looking forward to that. We'll have to do something special for that too. So yeah, make sure you hit the bell, have that little notification switched on, and subscribe. Awesome. And I do go live every single Sunday, 7 o'clock UK local time, which is roughly GMT. We're still in GMT +1 at the moment, but I think at the end of October that changes back to just GMT. Okay. So this is the algorithm, odds and evens. What we need to do is figure out which coordinate we want, which pixel, using the very long addressing method, maps to our rows and columns. So this is what it actually looks like. So we use a modulus function, which is the percentage, and modulus basically just divides a number and gets rid of the remainder. So it's nice and clean, and we can say if the X value that we're looking for, so that's the columns going across, if that's divisible by 2, then it's an even, and we need to apply one particular formula. If it's odd, then we need to apply a different formula. So very nice and simple to do this. So if it's even, then we basically just say the position is going to be like what the actual number of the LED that we're addressing is the Y, which is the columns, plus X, which is how many pixels. I always get my Y's and Z's mixed up. So X is across, Y is down, isn't it, on our particular example? So X times by the number of lights per column. If the position is odd, then we basically just need to add 1 to the X position, times that by the number of lights per column, minus Y minus 1. And that will get us there. It seems a bit of a funky formula, but it works, trust me. I had to sit down for about 5-10 minutes and figure that one out, as well as drawing out that diagram so that I could really get a feel for what this thing looked like. I did quite a bit of testing, and it works as I expect. And then the last line there, self.led strip set RGB, use that position to say addressable LED number, whatever, set the red, green and blue value of that pixel. And we basically run that for every single pixel on our entire grid, if we just want to do an entire pattern. So some of the issues that I came up against whilst putting this together, I knew I would have quite a few, and I read a really good quote today. It was saying about when you do your best work, you're always on the cusp of failing, because if you work in your comfort zone, you're never really going to succeed and stretch yourself. So your best work is always on the cusp of failing. So if you're in that kind of zone, you're probably doing your best work there. So gluing the LED strips to the coat using that Gorilla Glue wasn't the best option. I could have, and it was a bit over-engineered, I could have just pulled the strip off the back, the adhesive, and just stuck it to the coat, and it probably would have got quite a good connection. Not weatherproof, but probably would work okay. So that's the first thing I could have done. The next one, the coat size. So Archie's a medium. We had some different coats. In fact, where have I got the others? I'll show you the coat we've got for Mini because it's exactly the same. Tries not to drop anything. I like how it went to the I'll be right back thing when I dropped everything. That was just a pure fluke. So I've got one of the coats here. Let me just go full screen for this. So this is one of the dog coats. This is a Mini's dog coat. And what we did with the other one, we took the hood off basically because the sound was sort of making them quite nervous, and they didn't really need to have this. It was more just a surface for the LED strips to go on the back of, so you can see that. And it's PVC. That's what the material it says on Amazon, I think, where we bought this from. But I'm not sure what the best type of glue is for this. So when I read up on that online, it said anything that's like is it a cyanoacrylic or something? Basically, super glue or concrete cement will be sort of ideal for that. The flexible, the flexing of the solder joints, I thought that would be my biggest problem, and that didn't happen at all actually. So those little plastic strips really help with that, and that was again a bit of an over-engineering. When I was thinking about the coats, we actually thought we could have one coat with the LED strips on and then another coat on top to make it waterproof. And we bought a bunch of these that all were supposed to be the same size, and they came back different sizes because they're from different manufacturers. But they are quite cheap. I think they're about £3 to buy, so they were very, very cheap. And almost disposable for this kind of usage. The other practical thing as well is there's a strap that goes underneath Archie's stomach, and his little wiener can get caught in there, so we need to make sure that that doesn't happen, because if he has a pee, it'll basically just go inside the entire thing, and we don't want that to happen. So where they have these, let's get this again, well, we have this, like this little bridge part, and you can connect that up. Let's see if we can get this into it so we can hold it right. So where it connects up like that, you can basically just offset it like so, and that's what we had to do, just to make it slightly further forward, more towards his front legs. There we go. There's another thing falling off there. So the other thing was the screw terminals. So when I put this coat on, the wire that's connected from the saddle that he's wearing, that went underneath the coat rather than over the top of the coat, and basically it was under pressure. When he did a shake, it basically just ripped it out of one of the screw terminals, and as a nice clean pull, it was just the soldered piece of wire just came out. But I didn't have a little mini screwdriver with me at the time, so I had to just shove that in, and you can see on the video that I'll show you in a minute that sometimes it shorts out, well, not shorts out, but just disconnects and has a bad connection. I was in two minds about this, whether I think the screw terminals are a good idea or a bad idea. They're great for just getting a good connection, but they will pull out quickly if there's any sort of pressure applied to them. So that's probably a good feature actually, but it was a problem in the field. But I didn't get any of the actual solder points being damaged or being pulled out at all, so I was really pleased about that. And then just on a practical level, the light pattern, I have one light pattern which is the Chaser LED pattern, and that didn't work very well. I'll show you what that looks like if I go to the camera on this one here. So if I just press the button on the harness, just find the right one. There we go. So that's the RGB Chaser pattern. You can see that it's not very impressive. It's basically just got one LED going round every single one of the addressable strips, and it looked really cool in person. But when you actually see it like on a video or outside, it really isn't bright enough. It doesn't sort of capture people's attention very well. So that one wasn't one of the best ones. So this one was quite a good one. It's kind of like a glowing one. That was quite a nice pattern. And this one where it kind of glows and then goes off, sort of a strobing pattern, that's quite good as well. So I'm not showing you all of them just yet. I've got a bit of a demo to do in a second, so we can look at some of them again. So yes, all these different heavy objects I had was basically just to squash down and give a nice connection between the glue and the surface that they were gluing to. Now the good thing about that Gorilla Glue, it really is clear. It dries like like a rubbery kind of texture, and it's completely clear, so it really did work well. We could have done that to glue them underneath, and if we'd have put too much on there, you wouldn't have been able to, it didn't diffuse it or anything, it was just perfect. So that's good. Okay, let's have a look at the code and have a bit of a demo, shall we? So before we have a code demo, I want to show you a little video that I made of Archie on a walkabout. So let me just show you that video now. So at this point there's a guy walking behind me, and I didn't realise, and he sort of tapped me on the shoulder and he's like, I want to take a picture of this, I have to have this. And then somebody also said, are you a member of Blackpool Illuminations? Nope. Just a guy who likes making things and then making videos about them on YouTube. Right, so what I'm going to do now is I'm going to go over to the code, and we can also have a look on the overhead. So if I go to this view here, we can have a look at what's going on here. So let me just get this down. So there's a couple of pieces of code that I've got in this project. If you want to get a code of this project, you can go over to github.com/kevinmcaleer/cyberdog and you can download a copy yourself. So there's a fonts.py which I created for our project quite a while ago. I think it was the unicorn hat scroll that I created. So I created my own font and basically just use that to address each individual character as a grid of X's, and we can figure out, you know, if there's a 1 or a 0, we can draw the individual pixels of the characters. I've then got this LED array, which is just a library I created for doing things to do with the LED arrays, things like converting RGB values to hue saturation values and backwards, things like that, as well as just the X and Y coordinate for the grid. That's also in there too. The other thing I did was create this standalone code version. So I think the Cyberdog code, which is here, is for doing the wireless access point stuff, and then the standalone stuff runs on the Plasma 2040. So the bit where they talk to each other and send commands, that's the piece of code I need to do next, as well as text scrolling. Okay, so we're going to have a look at the standalone code, and what I'm going to do, I've got two versions of this depending on which RGB LEDs I'm using. So let me just find it on here. I just want to show you the line that basically just sets the array up. Let me find that. Because yeah, it depends on which one we're using. It's actually in the RGB LED array actually, so let's just bring that one up. There we go. So on this one I'm using the WS2812. You can use the APA 102s as well depending on how many cables you've got. So the WS2812 has just 3 cables, a ground, a data and a 5 volts, and therefore we only need to know what the Plasma 2040's data pin is. If you're using the one that's got 4, you basically just change this WS2812 to APA 102, and then you just add to the back of that like Plasma 2040.clock CLK, like so. It's catching up with me there. Oops, just with one C. Like so, that's what you would need to do. So let me just undo that because I want this to work. Okay. So yeah, you can see in there we've got things like the hue saturation value to RGB. There's a bit of code for doing that. We've got some other bits and pieces in here as well. So let's have a look at those. How many lights per column do we have? So each column is going down. We have 8 columns, which is what the columns is, and then lights per column is 36. And the number of LEDs is the lights per column times columns, not surprisingly. So I set the hue value to be 1, which I think is a nice red colour. It's solid red. I then set the saturation and the brightness to 0.25, so we can play with that and make it really, really bright if we want to. You can start coming up against, depending on how many LEDs you have, the power budget being over budget, and basically it will then get the voltage protection kicking in from the Plasma 2040. You then got frames per second, you've got the speed, which we use just for doing some of the pausing, and the offsets and gap, that's to do with the text scrolling, so we're not going to look at that today. So we've got a piece of code there for doing HS hue saturation value to RGB, and then backwards, RGB to HSV, so there's some code for doing that. One that basically just clears the grid, and then we can set a pixel RGB, and there's that piece of code that we looked at earlier, depending if it's an odd row or an even row, and we've got the same for HSV as well. And then I've got 2 pieces of code remaining. So we've got a display character. This is for the text scrolling. That's not working properly yet, so I'm not going to show you that, but that's in there. And then the show message basically just takes the entire message like hello world and then breaks it up into each individual character and then sends that to the grid. And then we can have some code that basically just moves that across in a loop. And then this one, again, this looks really inelegant, and there must be a much better way of doing this, but depending on what the character is, we can then basically just display that character. So that does it for every single uppercase, lowercase, numbers, and then some non-alphanumerics as well. So that's what's in LED array. So in our standalone code, we bring in that LED array, we bring in time and sleep, we bring in plasma, and the Plasma 2040 code, and Pimoroni have also got some nice button codes as well for any button that's used on their products. So I'm using the batteries included Pimoroni MicroPython build for all this code as well. So I then create an LED array using L. I set the brightness to be 0.35, so it's about 35% brightness, the saturation to 1, so it'll be full colour, and then the hue to be 0.1, and then the glow brightness, the speed, direction, off chaser numbers. These are all different pattern variables that I need to store. So I've been asked a question there, are there 46 LEDs per strip? There's 36 LEDs per strip. It depends, so you can see there, on this particular example I've got here, I think I took half of them rather than having the full 8, so it depends what you want to do. This, you can change this number here to set the number of LEDs. So this little tiny strip I've got on the desk here, that's probably got about 36 on it there. We could count them if we wanted to, but you can see that's working quite nicely there. So I've got a couple of functions that define the different light patterns, and these usually just have some kind of loop in them, and they'll take a value and they will do something in the loop with that value. So this cycle one takes our current hue value and the chaser number, which is like just a reminder of which current pixel you've got lit up. So if the current chaser number is greater than the number of LEDs, we want to reset that back to 0 so it doesn't fall off the end, it comes right back round again. We then set the hue saturation and value of the current chaser number, which LED is currently lit up. We pass in the hue saturation and value, and then what we do is we increase the hue by 0.01, so we get a really slight increase of the colour, and you can see that's what's happening on this one here. We just get the LED values increasing, and then at some point when hue is greater than 1, because it can only be 1, we need that to be then set back round to 0, and 1 and 0 are actually the same, they're both sort of solid red. And then we sleep for whatever that speed was, 10 times 2, so that's 20th of a second, is it? 20th of a second. And then we increase that chaser number, make that +1. If you remember at the very top, if that's greater than the number of LEDs, we reset that anyway. So that's what the very first one does, and that's called cycle. We then got chaser, which is that single LED that gets lit up. So again, we use that chaser to keep track of the current LED. We set the value of that, and if the chaser is greater than 0, then we light it up. We then increase the chaser number. Oh, actually, we check to see the chaser number -1. We want to erase the previously lit one because we only want one LED lit up at a time. So that's what's happening there. We increase the chaser number. We change the value of it as well. So as it goes along, it's also changing in color value too. Then we've got pulse. So again, we have the same thing about the chaser number. We just check if it's greater than the number of LEDs. We'll probably put that into a separate function, seeing as we're doing it every single time. We look at the direction. So I wanted this one to glow and then reverse the glow. So there's kind of a direction. Are we going up in value or going down in value? So that's what direction does. It's a Boolean, it's true or false. So if the direction is true, then for iron range, the number of LED strips, light all the LED strips up with a current glow brightness. So whatever that is. So it's going to go in brightness and then reduce in brightness. So we set the speed to speed. We set the glow brightness to be whatever it is plus 0.01. And then the hue as well to be 0.01. And then we just do some checks to see if the hue and the brightness are over whatever we want that threshold to be. So you can see that I'm capping the brightness at 0.5. It's never going to go above full brightness on there because it gets really bright. And then if the direction is not true, if it's sort of not the direction, we basically just do the opposite and then we just minus off the values instead. You can see that we're just changing the direction if we hit 0. So the rainbow one, this one will go through every single pixel and basically just set them to a solid color, and then it will increment that color, that hue, by 0.1, and we do that quite quickly. So we do speed times 8, and that's all that one does. It just goes through all the different colors and just checks to see if hue is greater than 1 and then sets it back to 0. We then flash some LEDs. We've got a red flashing one, so they'll be off or full on red, off, full on red. So we can see there, and I say full on red, it's half value red. So we've got the HSV to RGB. We put in there the hue, which is 1 for red. We have the brightness, sorry, the saturation, which is 1, which is full saturation. And then for brightness, we've got half again, just to make sure it doesn't go the full brightness. Then we set the LED strip using that RGB value that comes back from that. And we index the RGB LED with I. So we go through every single one of them. And then we just do a count and for the flash, and we basically just say, this is just like a delay, count to 10 and then go on or off. Red and blue is kind of like a police siren type thing. So it's red or blue, red or blue. So this one does another kind of count, and it just says if the flash count equals the rate. So these are just two variables we've got there. Then we just set them to either red or blue. And we just tidy those values up as well. So we just sleep whatever the current rate is, and we set the flash count to 0 once we've reached whatever that rate is. And we set the rate to be 3 to begin with. And then glow, I think we're nearing the end of the patterns now. So glow will just increase in brightness. And do we change the, we don't, yeah, we're changing the hue as well in that one. So it's very similar to the one above actually. It just doesn't, it increases in value and then goes back to 0, so you get this kind of strobing effect. Black is basically just switching everything off. So if off is true, then we just go through the array of LEDs and set them all to 0 so that there's no brightness at all. And then the do LED pattern basically just says, LED pattern is just a variable that just holds a number between 0 and 7. And depending what that number currently is, it will do either the chaser, the pulse, the rainbow glow, flash red or black. And we set the pattern to 0 to begin with. And then we've got like a name as well, just so I can echo them out to the terminal. So depending on which pattern we have, we can print out the name is. And then I read in the state of the button. So I read in button A. And if button A is pressed, we basically just want to do the pattern. We want to make that light up. And we can just change the LED pattern variable. And that loop will light that up in a second a bit further down below. Button B is like an on-off, so if we press it and the current state is off, we want to turn it on. If it's on, we want to turn it off, and we just make it everything black. If it's not off, then we just do the LED pattern, and that's it. So let's run this code. We can see it's actually running here at the moment. Let me just get this into view. You can see there we've got the current one. So if I press the A button on the saddle, this will change the cycle. So you can see there, that's the chaser, and it's just going around each of the LEDs and changing its hue value. If I press the next one, we're now on, we can also see here we're at pulse. This is pulsing through the colours, going from full brightness, half brightness, down to 0, but changing the colour as well. The next one is a rainbow, so it will just cycle through different colours in a nice kind of gradual change. Looks really soothing. Press it again, this is glow, so it's going to go from nothing to brightness and then nothing to brightness, changing the hue as it goes. The next one is flashing red, so on and then off, on and then off. If I press it again, we've got red and blue, so this is like a police flashing siren thing. And number 7, if I get it to actually accept that one, is black, so it hasn't actually turned everything off. But if I press the B button, that can toggle whether we've got a pattern. So if I just go A and I press that B button there, I can turn that on and off just by pressing it, and it will just cancel all the lights on there. So there we go. Now what I did as well with this is I saved this code as main.py on our main one over here. So if I kill the power on this, or there's any kind of disconnection, let's just kill the power. So if I press that, it's running completely from battery at the moment, so I can kill the power like so. I can cycle through just by pressing the harness. There we go. Now because you can see what's happening at the moment, the battery is actually on its way out on this one, and what's happening is the LED pattern is saying give me the full brightness, and it couldn't deliver that, so it was catching itself. I plug that in there, we've now got, let's just give it an off and on again. Just press reset, which as well we have a reset button, and it'll go back to that original pattern as well. There we go. So it's now just going through the usual kind of pattern. You can just see it in the background there. And if it glitches out like that, that usually indicates that there's a power issue and it's not getting enough power from the board. And it's probably because I need to charge the battery up. Even though I'm delivering some power through the Pico can't deliver the full value that it needs to on there. I don't think I've got another one to hand to actually provide it the power that it needs in the right type. So it's probably just going to do that. But anyway, cool. So what else did I want to show you about that? So I've got 2 of these. I've got the blue one, which is there. That's Archie's saddle. That's the one that's been field tested, and then we have the other one which is here, which is Mini's. So if I just disconnect this, I can sort of show you this a bit better. So you can see there it's like a complete arc shape. Now there are these little screw things poking through, and I can either put some nuts on the back of them to hold things in place, but they're pretty robustly on there. The grip on the PLA is sufficient for them not to fall off. But obviously I don't want that scratching my dog, so that's why I've got that piece of foam, which you can probably see on the other one. If I go back over to here, see that piece of foam? That sort of just sits between the dog and the arch and stops it sort of rubbing against that. And the other cool thing is we have this this wire we can very easily disconnect from the RGB LED strip, and that just means that we have the arch there, and we can easily take out the battery, exchange it for a different one, and then plop that back in there like so. And then we've got the power button on there, so we can press the power button, and if we've got enough power, that battery's pretty flat actually, so there's not much power going on there, so I can just exchange that for a different one, plug that in like so. If this one's got power, we can press that on, and I think they've all got they've all been flattened by yesterday's shenanigans. I need to charge them up. Now, to charge the batteries is really simple. Let me just pull that out there. We can just leave it actually plugged into the LiPo Pro and basically just provide some power there. So if we just plug this wire in here, you can see the red light has come on, and that's now charging up. So very easy to charge these, and I understand Pimroni are looking at potentially doing a different LiPo Pro, Amigo Pro that's got many different charger connectors on it. I'd be very interested in that, so I can have a whole bunch of these for all different projects. I've got these in mind for another project soon as well, so it'd be great if we had quite a few of those. Cool, so let me just go back to our keynote. We'll look through our demo. We've done a bit of a code look at. So yes, I wanted to bring your attention to kevsrobots.com. So this is the website I'm currently pouring all my effort into to build out. So there's loads of build articles on there. There'll be an article going on about Cyberdog very soon. I've also been reached out by Magpie magazine. They're really interested in doing a feature on this build as well. There's also the free STLs. So each project I do has like a code repository, has a YouTube video, and probably an article as well about how I built this and the fusion design and so on. So if you want to grab hold of the STL files, that's where you'll find them. There's all the links to every video I've ever done on the video links page. And I've also started to build out two things, a review. So I've reviewed the Inventor 2040 and also what's the other one that I've done? I've done another review anyway, and you can find them on the reviews page, or if you want to look at the gear list, the gear that I recommend, they'll be pulled from the reviews. So you can either go to the gear list and look at things that I'm like and interested in. So for example, I might do a review on these amazing wire cutters. They've got some, well, these are crimpers actually. So I use these crimpers when fixing my 3D printer. I had some issues with my 3D printer recently, and I have these JST connectors, a whole bunch of them with the little wire things in there. And previously I did have some crimpers, but they weren't very good. They weren't very well manufactured. So when I used them, every single thing I connected had a really poor connection to it. It either cut the wire completely or it just crushed the crimp thing. So these ones are really good quality, and this is the kind of thing I want to add to the build, to the gear list, so I can recommend things. I've got another set as well. Same company, I think, that produces these, Engineer, and these ones have that nice bar at the back, so you can always define the length of the wire that you're stripping. So these are a couple of the things I would probably be adding to my recommendations list. So the gear list and the reviews sort of go hand in hand. So check out kevsrobots.com. And this actually runs on the Raspberry Pi Array, which is just behind me here. We had a bit of a power glitch before, so that went off and it came back on, and it actually gets rebooted every single evening at midnight UK local time. So for about 5 minutes there might be a little bit of outage there, but other than that it's all running in Docker containers. You can go over to one of the links on Kev's Robots to Clustered Pi, and you can read all about that as well. So that's one of the things I wanted to draw attention to. And the other one is our Discord server groups. This is a really growing community, a really vibrant community of people who are robot builders like yourself, people who like to tinker with electronics, all come up against the same kind of issues in various different things, so you can help each other. Because I don't know all the answers. I know a lot of things, but I don't know everything. And there's probably somebody on our Discord group who does know the answer. So check out Discord. And you can go to the nice new link, which is kevsrobots.com/Discord. Nice and easy to find. I've figured out how to do pretty URLs using Jekyll and Markdown. Okay, and if you want to follow me on social media, you can check out Instagram. I post pictures and video clips on there, reels, over on Kevin McAleer. So you can at me on there. And if you go to Twitter, I'm always tweeting stuff all the time. So check me out on Kev's Mac. And you can find stuff. You can see a nice picture of Archie, who's in our studio today. Is he still asleep, or is he... He's looking slightly, what's the word, pensive there? No, he's got his eyes shut there, you can see. There he is.
Could get a second special guest.
Could get he had his hat on before, didn't he? So You put it back on and you can show Archibald to the world. So I think that's everything I wanted to cover off on today's show, and then we'll have a quick look on the Q&A and see if there's anything anybody wants to know about. So if you want to help support the show, you can do. You can go over to the super thanks, but Minnie just joined us in the studio as well. She's running around. Yes, if you want to help the show, you can do a super thanks on YouTube videos. There's a little thanks button on underneath next to the bell and subscribe and all that. There's also a join button. You can join the YouTube membership program. We've got quite a few people starting to join that now, so thank you so much if you've done that. You can do a super chat if you're watching live now. You want to sort of bring something to my attention, just say hi and support the show. You can do that. Just making sure I've got all the alerts set up on there, which I have. And you can also buy me a coffee down in the corner there. We've got buymeacoffee.com/Kevin McAleer. And if you visit that, you can also help support the show. So I think that is everything I need to talk about today. Let me just see if there's anything left. Nope, I think that's pretty much it. Finn, that's it. We're over. We're all good. So this is the point in the video. If you're watching live, you're going to check out some cute chihuahuas. You can see them there. So this is Minnie. She's wearing a mini dress there. This is actually looking a little bit surprised. Actually, let the world see you. There he is. This is our Archibald. Isn't he just the cutest dog you've ever seen in your life? There's nothing going on in that head, is there? There's just fluff and bubbles. There you go. Cool. So let's have a look at the chat. There's there you go. Yeah. Let's have a look at Mini Girl. Let's say hello to the world, Mini Girl. She's like, don't pick me up. I don't like being picked up. There she is. My baby girl. They can just hang out down there now. Okay, so let's have a look what people have been talking about in the chat. There's been quite a bit of chat today, so let's have a see what people are talking about.